Hello everyone, let's talk about data frames. Just like we were able to create series from a Python list or from a Python dictionary, we are also going to be able to create a data frame from multiple different options. Recall that in last lecture, I mentioned that the data frames column can be thought of as an individual series. So that's going to be the first option that I'm going to use in order to create a data frame. I'm going to create a data frame using a dictionary of series. I can also create a data frame using dictionary of lists or by using any of the other combinations like list of lists, dictionary of dictionaries, lists of dictionaries. We'll be covering examples for each of these options. Let's get started with dictionary of series first. I have an example where I have two series defined. The series are defined using Python lists. The first series contains a list of string values. The second series contains a list of integer values. Let's assume that these are all players in a particular game, and the second series correspondingly represents each player's score. Let me show you how we can access the type of a data frame in Python. So I can simply use the keyword data frame because I used the from pandas import data frame earlier on in this notebook. This is going to be the output that you see when you call the built-in type function on any Python data frame, pandas data frame. Just like any other object instantiation in Python, we are going to use parentheses to create a data frame. And I want to create a data frame from a dictionary of series. So I'm going to go ahead and enter curly braces. And for the first series, I'm going to give my key as player name. And I'm going to mention the series name itself. That's going to be the value. And for the second series, I'm going to have score as my key and call2 is going to be the value itself. Let's talk about the data frame representation over here. Notice that you're now getting a two-dimensional structure. Unlike the series, you have multiple column values here. We are going to have four different terminologies associated with the data frame. We are going to have a row index and a row integer position, and we are also going to have a column index and a column integer position. That's because we are going to have multiple columns when it comes to a data frame. Let's talk about the column index over here. I'm explicitly mentioning the column index by giving key in my dictionary of series. So column index is going to be player name and score over here. The row index, on the other hand, is getting the default value from the row integer position. I'm not really explicitly mentioning an index as I'm creating each of those series from a list. So that's why you're seeing the values as 0, 1, 2, 3 for the row index. Let's talk about the next option here. How do we create a data frame from a dictionary of lists? Instead of using the series here in my dictionary, I'm going to directly use the list, and that's going to give us the exact same data frame as we saw in the previous example because we're not changing anything at all. How do we create a data frame from a list of lists? Let me go ahead and copy the data frame line over here. And I want to create a list of lists here. So I'm going to use square brackets. And I'm going to represent each player using a list. And since we have 4 players, I'm going to have 4 lists over here. My first value is going to be player name in my list, and the second value is going to be the corresponding score. So I'm going to say Alice 6, Bob 7, and then I'm going to say Cindy 8, and finally I'm going to say Dan 9. Notice that this time we are getting a different column index. That's because I'm not explicitly mentioning what the column index is in this particular format. Let's go through the last couple of options over here. The next option is going to be dictionary of dictionaries. Let me just copy paste the previous version, and I'm going to erase the things inside there. I want to create a dictionary of dictionary here. So I'm going to use curly braces for the outside ones, and I need to use curly braces for the inside ones also here. I'm actually going to create two dictionaries, one to represent each of the columns over here. So I'm going to have, player name as my first dictionary's key, and the second dictionary's key is going to be score. And inside my dictionary, if I want the exact same representation as before, I'll have to use 0 as the key and Alice as the corresponding value. And let me go ahead and show you that version. Then I'm also going to show you how to use a meaningful key for your dictionary over here. Let me go ahead and define all the values, and then I'm going to define the corresponding scores over here. So I'm going to say 6, 7, 8, and then score of 9 for Dan over here. Right, notice that right now we are getting the exact same data frame as in the previous examples, the ones other than the list of lists. Instead of using the integer keys here, if I were to use meaningful keys, say A for representing Alice, B for representing Bob, and C for representing Cindy, and D for representing Dan. Let's say that I'm also fixing the corresponding keys in the second dictionary, which represents scores for each of the players over here. Then right now I'll get a meaningful row index than the previous values of 0, 1, 2, and 3. So the last option is going to be to create this data frame from a list of dictionaries. So I already have a list over here. I want to define a dictionary for each player. So I'm going to do that by saying player name as the key, and the value is going to be filled in later. Let me define the next key also so that I can actually copy paste this empty dictionary over 3 times instead of having to type all of that over and over again. And now I'm going to go ahead and fill in the values. So I'm going to say Alice for the first player, Bob for the second player, Cindy for the third player, and Dan for the last player. And the corresponding scores are going to be 6, 7, 8, and 9 over here. Right, this gives us the original representation because I am once again using lists, so I can't really define specific row index directly in this representation. So let me show you how to rename the row index when we are creating this data frame using a list of dictionaries or any other representations where we couldn't actually define a row index. So the data frame type has an index field which you can mention when you instantiate data frame. Notice that I'm mentioning index outside the data structure which actually represents the data frame, and the index takes a list of values. So I can explicitly say A is going to be the row index for the first dictionary, and B is going to be the row index for the second dictionary, and C and D are going to be the row indices for the third and fourth dictionary. Notice that now we are getting meaningful row index values. All right, let's talk about how to perform data lookup, and we are first going to do a recap of series data lookup, and then we'll talk about how to do data lookup using a data frame. Recall that we covered 3 different options for data lookup in series. The first one is by using index and explicitly saying .loc, which stands for location. And that's going to look up the index X, and it's going to give the corresponding value for us. The next way is to use the integer position, and by explicitly using .iloc, which stands for integer position location. And this once again is going to give us the value corresponding to the integer position X over here. Third way is by simply saying S of X, and this is going to cause a conflict if you have both integers for index and also the integer position. Sorry, I mentioned the correct terms. It's going to cause a conflict when you have both integer value for index and integer value for integer position. So how does Pandas resolve that conflict? It will always take index into account whenever there is a conflict. So you can just say S of X over here. So let's use the first player name series in order to go through this particular recap of all the data lookup. So I'm going to go ahead and define a series called call1. So if I say call1.loc of Bob, that's going to give me the corresponding score for Bob, which is going to be the value 7. So if I say call1.iloc of let's say 2, that's going to get me the value corresponding to Cindy, right? That's because Alice is 0, Bob is 2. Excuse me, Alice is 0, Bob is 1, Cindy is 2. Sorry about that. So let's go through one more example of iloc. I can also say negative values in iloc. I would strongly discourage you from saying call1 of negative values. That might give you unexpected results sometimes. So since I'm talking about integer position here, I can say call1.iloc of -1. That's going to retrieve the last value here, which is going to be 9. So the other option is to say call1 of say 1. That's just going to give me the value of Bob over here. That's because in this particular example, there is no conflict between index and integer position because we have string values as index over here. All right, that's the quick recap about series data lookup. I have the series data lookup also listed down here so that you can compare how DataFrame lookup works as opposed to a series lookup. Let's talk about DataFrame lookup. So we have the loc and iloc features in a DataFrame also. So when you say d.loc of X, you're going to look up a specific row by mentioning the row index. X is going to represent the row index over here. So recall that in DataFrame you have both a row index and a row integer position. So you're going to be able to use d.iloc of X, where X is an integer position. So you're going to look up the corresponding row by the row integer position. So just like in a series, we can also say d of X. You might think that this will give us a row. Unfortunately, that's not how Pandas data frame is defined. D of X is going to give us a column, and you're going to look up a column by mentioning column index over here. So if you try to mention a row index there, that's going to throw an error for you. I'll show you an example of that. So far we spoke about how to retrieve a row and how to retrieve a column. So let me show you exactly how to retrieve one value from a row. So that can be done by mentioning two different index positions. So the first index position is going to be for your row index, that's going to be X. And the second index position is going to be for your column index, which is going to be Y over here. And since I'm using LOC, I'm talking about index here. We have a counterpart way of doing that by using row integer position and column integer position. That's by using d.iloc of X comma Y representation, where row integer position is X and column integer position is Y over here. All right, let's go through a set of examples over here. Before that, I'm going to go ahead and capture this last data frame representation into a variable called df so that I can keep using the variable df down here. So let's go through first LOC example. So let's first display df over here. So we have row indexes A, B, C, D and column indexes player name and score. So df.loc of is going to expect a row index. So let's say that we want to get Alice related details here. So I'm going to say df.loc of a. Let's see what exactly df.loc of a here returns. So I'm going to call the type built-in function on it. Notice that it returns a series. So not only is a column represented as a series in a data frame, a row is also represented as a series. So if you take out a row, you're going to get a row series, and if you take out a column, you're going to get a column series. So let's talk about the terms that we see in this display over here. So we are getting a series, and my index is going to be the column index because we are getting a row series over here. So my first value is going to be Alice and the index is going to be player name, and the second value is Alice's score and the index corresponding to that is going to be the column index. The term name here refers to what exactly we searched within that data frame for. Unfortunately, they should have probably used the name search here instead of using the name, which is a little bit confusing. We did a location lookup by A, so you're going to get A in that. And you're going to get data type as object because we're dealing with two different data types in this particular series over here. Alright, so that is df.loc of x. Let's talk about df.iloc over here. So I'm going to show you df.iloc of 1. 1 is going to be Bob's row here. So that's what you're going to get over here. So just like in your series, you can also use negative integer position value in ILOC. So if I say -1, we are going to get Dan's associated details over here. Let's go through the next option, which is of the form df of x over here. That's going to retrieve a whole column for us. So we have two columns, player name and score. So let me go ahead and try to access the score column over here. Notice that once again we will get a series when we try to access a column. So let me go back to the previous representation over here. We are getting index in our series as the row index. So if you try to extract a column, your row index is going to become your series index. If you try to extract a row, your column index is going to become your series index. Hopefully that makes sense. Alright, so that's going to be df of scores. Let me show you what happens when you try to access df of A. A is a row index over here. So this particular access of df of A should throw an error, and as expected we are getting key error. So you cannot say df of a row index, you should always say df of a column index. Alright, the next set of options is for you to look up a specific value by passing both a row index and a column index. So let me show you how you can get Bob's name over here. Bob's row index is B, and the name of the column, which is the column index, is going to be player space name over here. So if I do this now, we should be able to get Bob. Let me go ahead and display the data frame here so that we don't have to keep scrolling up there. Alright, what if we wanted to get Bob's score? We'll have to say df.loc of Bob's row index and the column index for score, which is going to be score. Then you'll get a value of 7. That's to access both of these column values against Bob. Let's go through the example with the ILOC over here. Let's say I want to pass row integer position and column integer position. Let's say that I want to get Dan's uh, let's say play dance name. So if I say df of iloc of -1 0, that's going to retrieve dance name. If I say df of df dot iloc of -1 comma -1 or -1 comma 1, that's going to retrieve dance score over here. Play around with all of the options so that you're able to understand all of the data lookup over here clearly. All right, the next thing which I want to talk about is we spoke about how to create a data frame and how to access values within it. Let's talk about how to set values to a data frame specifically. So we can use the same df.loc of row index, comma column index format, and then I can say equal to new value. So let me go ahead and say df.loc of row index b, column index score, and I'm going to say that Bob's score is now going to be updated to a value of 12. And if I go ahead and display data frame after that, you're going to say that Bob's score changed from 7 to 12 over here. Just like you can use plus equal to in a series, you can use plus equal to also in your data frame access. So let me go ahead and increment Bob's score by 3. You're going to see the score as 15 now. You can also use ILOC to update the values in your data frame. Let's say that I want to update Dan's score. I'm going to be able to do that by saying df.iloc of -1 comma 1. Dan is given by the last value over here. So the row integer position is going to be -1. Column integer position is going to be 1. Player name column is column 0. So score column is going to be column 1 over here. Notice that Dan's value changed from 9 to 11 when we did a plus equal to 2 over here. Pandas is a really cool and awesome tool. So you're going to have majority of the mathematical functions that you can think of already implemented to you in Pandas. Let me show you how to compute maximum score for a column. First of all, you need to retrieve the scores column by saying df of score. And you can compute the max simply by saying dot max. And this function is going to enable you to compute the maximum score. 15 is the maximum score in your score column. Similarly, you're going to be able to compute the mean of a particular score just by saying of mean. As I said, Pandas is very powerful and you can very easily compute a lot of mathematical outputs just by using the existing functions in Pandas. Alright, I am going to wrap up this video here. In the next video, we'll start talking about slicing a Pandas data frame.